Hey guys, in this video we are going to solve problem based on what the DC-DC converter drive, in which the control mode here it is nothing but regenerative braking. This is a regenerative braking. This is the second control mode we are discussing. The previous control mode was the power control or the acceleration control. So this particular problem we are taking. So it is said that a DC-DC converter is used in regenerative braking of what? DC series motor. Now the DC supply voltage is given as 400 volts. So what all things is there, just to mark it up. So 400 volt is there. So I'll just write it down. So Vs is given as how much? 400, sorry, 600 volts. Next, the armature resistance is also given, as well as the RF, which is the field resistance given. Back EMF voltage constant is also given. Actually it is 15.27 millivolt per ampere. Okay, radian per second, that's the unit. And the armature average armature current is maintained to be constant at IA value is also given. Okay, rest all the armature current is continuous ripple free, that is fine. The duty cycle of the DC-DC converter is 0.6 we have to consider because it is 60%. 60% also is given. Now we have been asked to determine the first part of the question. First I will just write it down the given things. So it will be 10 to the power minus 3, so 0.01527 volt radian per second. In duty cycle K is also given 60%, which is 0.6. Directly you take 0.6. Now we will go for the first part of the question. So they have asked to determine first part of the question, A part, average voltage across the DC-DC converter, which is termed as VCH. So they have asked you to find out basically the VCH. Okay. So let us try to analyze that. A part we are taking to find out VCH. How will you find out VCH? 1 minus K into Vs. So what is 1 minus 0.6 into Vs is also given supply voltage 600. So when you calculate this particular thing, you will be getting 240 volts. So first part is done. Now let us go for the second part of the question, B. Again formula we are having for the power developed, Pg is equal to Ia into 1 minus K into Vs, or indirectly you can say it is Ia into VCH. Given 250 it is given. VCH just now we found out 240. So when you multiply both, you will be getting 60,000 watts or 60 kilowatts. The C part, equivalent load resistance of the motor acting as a generator, which is given by, denoted by R equivalent they are asking. C part is to find out the R equivalent. Now what is the formula for R equivalent? It is given by Eg divided by Ia. This is for the regenerative braking. So Eg divided by Ia. Ia is given directly, which is 250 ampere, but Eg is not given, right? Motor back EMF is not given. In order to find out Eg, we are having one formula, PCH plus RA plus RF whole into IA. It is not IRA because RF is also considered here, RA plus RF. Why? Because this is, they have mentioned it as series motor. Here you can observe this is the DC series motor. Okay, so that's why we have to consider RA plus RF. Now what is VCH? VCH is given directly 240 volts plus RA into RA plus RF. So RA is given as 0.02 plus RF value is 0.03 into IA value is 250. So you will be getting EG value as 252.5 volts. So R equivalent becomes what? EG by IA. So EG value is 252.5 divided by IA, which is 250. You will be getting the answer as 1.01 ampere. 1.01 ohms. Next, the C part is also done. Let us go for the D part. D part they are asking us the minimum permissible braking speed, and E part is maximum. Okay, here minimum permissible braking speed. So in region 3 we are having the direct formula for that. So let us see that. So D part is minimum. They are asking the minimum breaking speed permissible, omega minimum they are asking. Rm Ia divided by kV into If. Now Ia we know, If we know, kV also we know. What is Rm now? Rm based on the motor it depends. Now Rm, if you want to consider for DC separately excited DC motor, it is Ra, armature resistance, plus any series resistance which is given in the question. Okay, but if we consider the DC series motor, Rm becomes Ra plus Rf plus any series resistance. Now here it is given as a DC series motor, so here we have to consider Ra plus Rf. There is no other series resistance, so we have to consider Ra plus Rf as Rm. Okay, I hope you understood. So Rm becomes basically Ra plus Rf into Ia whole divided by kV into Ia. So omega minimum becomes what? Ra value is 0.02 plus 0.03 into Ia value is 250 whole divided by kV value. kV value, as we know, it is, we have taken as what? kV, here it is there. Motor constant 0.00, 0.01, 0.01527. Now If value is same as Ia, as we know this is a DC series motor. If and Ia both are same. So can I consider it as 250 itself? That means this 2 gets cancelled. What is remaining? 0.05 divided by 0.01527. So you will be getting the answer as 3.274 radian per second. Always remember, whatever the answer of speed you will be getting, that is in radian per second. If you want to convert into RPM, what you are going to do? You are going to just multiply it with 30 by pi. Okay, in order to convert to RPM. So when you multiply it, you will be getting 31.26 RPM. This is the omega minimum speed. Okay, this is the D part. Let us go for the E part. E part, basically you have to find out the maximum permissible braking speed, omega max. Here also you have to do the same thing. Omega max you have to find out. Vs divided by kV into If plus Rm Ia divided by kV into Ia. This is the formula for omega max. In this we have to substitute all the values. Vs is directly given, which is 600 volts, divided by what is kV, it is 0.01527, into If is same as Ia, which is 250, plus Rm we just found out. See, this part is Rm, Ra plus Rf 0.05 into the, see, Ia and If is same, so 250 by 250 gets cancelled because this is a DC series motor, divided by kV value again 0.01527, right? So when you apply this formula, so you'll be getting the answer as omega max is equal to 160.445 radian per second. If you want to convert into RPM, just multiply by pi by 30. Okay, you'll be getting the answer as 1532.14 RPM. So this is the omega max value. Okay, the maximum braking speed. Let us go for the last DEF part. Motor speed we have to calculate. Eg is equal to kV into omega into If. Right, this is the formula. From this we can get the omega value as Eg divided by kV into If. Right. Now how to find out Eg? Eg is not given in the problem. Now for the DC series motor, Eg is equal to VCH plus Ia into Rm, not Ra. It is Rm. Rm is basically Ra plus Rf. So VCH is how much we calculated in the first part of the problem. You can see over here it is 240 volts divided in plus Ia value, it is 250 into Rm. Rm is basically Ra plus Rf, which is again the same thing, 0.05. So when you multiply and add this, you will be getting it as 252.5 volts. After finding out Eg, you have to go for omega. So omega is equal to Eg divided by kV into If. So Eg value is 252.5 divided by kV, EG divided by kV. kV value is 0.01527 into If is 250. So you will be getting omega value as 66.14 radian per second, which you can convert into RPM by multiplying with what? 30 by pi. So it is equal to 361.6 RPM. This is omega speed of the motor.